Dear learners, today I am going to take a unit which is entitled Propositional Logic and Predicate Logic. This unit belongs to the first semester Logic 1 paper, and the number of this unit is Unit 11. So today's class you will be able to know there are different forms of propositional logic. And again, we'll know that so far as predicate logic is concerned, we'll find that predicate logic deals with the substructures of both simple and compound proposition. So far as predicate logic is concerned, you'll also know from this unit that predicate logic has its own grammar to formulate statements which are considered well formed in logic. Predicate logic, another name of predicate logic is quantifier logic. Forms of propositional logic. So far as forms of propositional logic is concerned, we'll find that deontic propositional logic or epistemic propositional logic are two other forms of non-truth functional propositional logic. The former involves introduction of operators similar to the English operators. It is morally obligatory that, and it is morally permissible that. Again, the truth value of a statement in dialectic logic does not depend wholly on truth value of the parts. Again, so far as epistemic logic is concerned, we'll find that it involves the addition of operation similar to the English operator. It is known that and it is believed that. Now we'll discuss about sentence, proposition and statement. Now what is a sentence? A sentence is a set of words arranged in a grammatically correct manner to form a meaningful expression. In other words, so far as our sentence is concerned, we'll find that it is a word or a group of words conveying some meaning. For example, Sita is pure, come here, are you alright? These are the examples of sentences. Now, so far as sentence is concerned, a sentence represents a broad category which includes many different types of sentences. For example, it covers indicative sentences, interrogative sentences, exclamatory sentences, and etc. etc. Now we'll know what is a proposition. So far as a proposition is concerned, a proposition, it is an expression which can be either true or false. Okay, a sentence, it is not necessary in the case of a sentence that we'll have to find out the truth value of that particular sentence. It is not necessary that it will have to be either true or false. But so far as a proposition is concerned, in case of proposition, it will always must have either true or either false, but cannot be both true and false in the same time. Cohen and Nagel, they have defined these two logicians. Cohen and Nagel, these two logicians have defined propositions as anything which can be said to be the truth or false. For example, Lachit Barphukan was brave, art is a planet. A proposition is the basic unit of logical thinking. The logical proposition has its nearest approach in a sentence indicative. So, it is true that every sentence is a proposition, but every proposition is not a sentence. We have already known that what is a sentence and what is a proposition. Now, what is a statement? A statement is understood as what is said in a declarative statement. In Encyclopedia of Philosophy, a statement is defined as a declarative statement or part of sentence that is capable of having a truth value such as being true or false. So, every kind of sentence cannot be a proposition or a statement, but every statement and proposition are sentences. Okay, it is worth mentioning that statements are also close to propositions. Now we'll come to simple proposition and compound statements. Okay, simple and compound, sorry, not proposition. We'll come to simple and compound statement. So far as the fundamental elements of propositional logic is concerned, we'll find that propositional logic are whole statements. Statements are represented by letters. Okay, and these letters are combined by means of the operator to form more complex symbolic representations. To understand the symbolic representation used in propositional logic, we must distinguish simple statement from compound statements. Okay. Now, what is a simple statement and what is a compound statement? We'll have to know it. A simple statement is one that does not contain any other statements as a component. But compound statement is concerned, it has different story. Again, simple statements are structurally simple. For example, some Indians are scientists, fast food tends to be unhealthy, Descartes is a mathematician, etc. They are very simple. Again, any convenient uppercase may be selected to represent each statement. That is, S might be selected for scientist. Again, we can use D for Descartes, you can use F for fast food, and like this. But a compound statement is one which contains more than one simple proposition as its component. For example, Mita is rich and smart. Either Radhakrishnan is a philosopher or a politician. Using these letters M, S, R and P for the simple statements, this compound expression may be represented as follows. Okay, Mita is rich and smart. M and S. Okay, again that means one word used to be used for rich and other is to be used for smart. Again, other Radhakrishnan is a philosopher or politician. Here you can use either R or P, because if we'll use both P for both the things, then it will not make any sense or it will not make any meaning. Compound statements can be of two types, namely truth functional compound proposition and non-truth functional compound proposition. A compound statement is truth functional if and only if truth values is entirely determined by truth values of its simple or atomic components. Again, so far as truth functional compounds are formed by truth functional connectives such as conjunction, negation, disjunction or implication, a truth function can be a proposition can be simple statements can be make a compound statements. As for example, Earth is a planet and it is round. It is a truth functional compound statement, and the truth value of compound statement depends on the simple components. Suppose Earth is a planet and it is round. So on the other hand, so far as a compound proposition is concerned, you'll find that compound proposition is a non-truth functional compound proposition, and if and only if its truth value depends on further information that the truth values or its components. For example, some people believe that the pyramids of Egypt are built by aliens. Okay, getting my point? In compound proposition, truth functional compound is used, and here truth value is depends on the information of the truth value of its component. Here they have, that is why they say that I have given you the example that some people believe that pyramids of Egypt are built by aliens. Its truth values further depends on a psychological fact of some people. Now, what is logical constant, propositional variables and propositional constant? Logical constants are words which are used to connect simple proposition to provide compound proposition and which express the form of structure of the compound proposition. Again, logical constant connect statements and therefore they are also called the connectives. Okay. Thirdly, so far as propositional logic are concerned, you will find that propositional logic uses 5 basic logical constants or connectives. We have already discussed about it, but still I am saying they are not, either or, if then, if and only if. Okay. Again, logical constants are represented by the respective symbols. The 3 connectives, not, and or, are also known as Boolean operator or Boolean connectives. Okay, because these 3 connectives are for the first time have been used by George Boole. So far as propositional variables or statements variables are concerned, you will find that those letters which can be stand for any simple proposition or as a whole are called propositional variable or statements variable. Lowercase letters of English alphabet, P, Q, R, S, T, this kind of letters are generally stand for simple or atomic proposition. So these letters are referred to as propositional variables. For example, if P then Q, P therefore Q. This whole argument can be represented in the help of propositional variable like this. P implies Q, but P horseshoe Q, P therefore Q. Hence, P and Q are variables because they can be replaced by any simple proposition within a definite range. In the above argument form, the variable P and P can be replaced by proposition. Okay, again, so far as propositional constant or statements constant are concerned, you'll find that the appropriate capital letters of the English alphabet, which are used to refer to the specific simple statements in a given context, are used. For example, we may use the capital letter E to represent art, P to represent planet, and etc. Now, what is statement form? A statement form is a sequence of statements variable such that when the statement variable are substituted by actual statements, throughout the result is an actual statement. The example of actual statement is like this: either the papers are difficult or the students are not intelligent. Okay, now either the train is late or the watch is fast. This here for one part is totally depend on the other part. Okay, there are two possibilities, either one possibility, and only one possibility can be true in this kind of statements. I have already told you about the different functions, but still I have mentioned here is that what are the truth functions and what are their symbolic representation. It is I have mentioned in this slide. Now, propositional logic deals with either type of truth functions apart from the three basic truth functions. One of the truth function is a stroke function. It is already I have discussed. Now, in propositional logic, truth functions are interdefinable. That means logical constant or the truth functions can be defined and reduced into each other. I have given one example. P dot Q, it can be represented again. It can be represented not within bracket not P or not Q. Again, P dot Q can be represented not P implies not, P implies not Q. So, one particular representation can be represented in different ways. Now, what is decision procedure? Decision procedures are those methods used in propositional logic to determine the validity or invalidity of arguments and argument forms, and also examine whether statements or statement forms are tautologous or not. There are different kinds of decision procedure. One of the important decision procedure is truth table method. What is truth table method? I have already discussed. Still I am saying here is that a truth table method can be defined as a tabular representation in which all possible truth values of a compound statements are calculated through a calculation of the truth values of their simple constituent proposition. In propositional logic, truth table method is considered as the most basic and important decision procedure, and this method is known as matrix method. Now we have shorter truth table method. About shorter truth table method, or another name of shorter truth table method is reductio ad absurdum. It is also been discussed in the previous class or the unit 7. Here in a propositional logic, in a shorter truth table method, it's constructed to establish directly invalidity or indirectly the validity of a argument, because here the truth value is considered as false, and by taking it as false, and in this method what we do, the technique is used to establish the invalidity of an argument, and there exists that at least one possible truth table assigned on which the premises are all truth while the conclusion is false. Indirect truth table provides a shorter and faster method for testing the validity or invalidity of an argument than the ordinary truth table method. This method is convenient in case of argument that contains a large number of simple statements. For example, an argument contains 5 to 6 different simple propositions. In the cases, shorter truth table method will be more beneficial. Now, what is formal proof of validity? Propositional logic adopts a deductive proof procedure that establishes the validity or invalidity of an argument. In this process, conclusion is formally derived from the premises to prove the given argument as valid. This proof procedure is also known as formal derivation or natural deductive or formal proof of validity or method of deduction or derivation of substitution. Now, what is predicate logic? Predicate logic is a branch of symbolic logic where we'll find that the internal structure of both the simple and compound propositions are studied. It is concerned with predicates or properties and things or objects to which the predicate may be ascribed. This logic is also known as predicate calculus. In this chapter, we are mainly concerned with first order predicate logic, and we can bring out some of the important points so far as the predicate logic is concerned. So there are some of the important ones which I have mentioned here is that predicate logic is the logic of properties and things to which the predicate may be ascribed. Predicate logic deals with the internal structure of both the simple and compound propositions. Predicate logic contains the entire proposition, hence it concerns with the symbols used in propositional logic. The logic has a set of new vocabulary and the language of its own. It has its own grammar to follow statements which are considered well formed in logic. Now the question is why we need predicate logic. Propositional logic sometimes fails to determine the validity of most valid arguments. In such cases, the necessity of predicate logic arises as it provides us with the method of proving the validity of a number of valid arguments which are invalid when symbolized in the notion of propositional logic. Predicate logic has dealt with those arguments which contains proposition whose structures are different from that of the compound or the truth functional proposition. For example, all scientists are atheists, Rashmi is a scientist, or therefore Rashmi is a atheist. This argument is obviously valid. Using statement constant, we can symbolize this argument in a notion of propositional logic as follows: P, Q, therefore R. Okay, P, Q, therefore R. This argument form is obviously invalid. Propositional logic is unable to provide the validity of this argument form. That is why to find out the validity of this argument, we have to take the help of predicate logic. Now, what is singular and general proposition? So far as singular proposition is concerned, we'll find that it is one which states that a particular individual possesses or does not possess a particular property or attitude. Singular proposition is very simplest kind of proposition. As for example, she is pure or Kalita is a poet. Okay. On the other hand, so far as general proposition is concerned, it asserts that some individuals, it may be even one individual or not a particular individual, or all individual possesses or do not possess a certain property. For example, all men are honest, some flowers are beautiful, no man is perfect, a teacher is learned. Now we'll know what is individual constant, individual variable and predicates. We can use lowercase letters of alphabet like English alphabet like A to W, which are used to denote particular individuals are known as individual constant. Their function is to denote one of the unique individual or object from the domain of discourse. Some of the reference remains fixed constant within given context. They are called individual constants. The singular terms are represented in predicate logic by the individual constant. Usually, an individual or an entity, any individual or an individual entity, it is referred by the first letter of the name of that particular individual or that particular entity. For example, we may use R to denote Radhakrishnan or Rashmi. We can use S to denote Socrates or Sita or Shyam. We can use D to denote Delhi or Divya or Dibrugarh and like that, so on. On the other hand, small letters towards the end of the alphabet such as X, Y, Z, which are used to denote any individual as known as individual variables. They stand for objects or individual in the domain. Individual variables are by nature quite different from the constant. A variable is a placemaker. It is not like a particular name. They refer to some unspecific individuals. For example, X is an individual variable and it is the expression capital H and small x, because X refers to arbitrary entity within the specific class. Predicate logic, as its name suggests, is concerned with predicates. Now, what is predicate? Predicates are words or expressions that we use to refer properties or attributes that things have. To become a predicate, you need a subject. Okay. For example, Socrates is wise. Wise is the predicate because it is the attribute, and whose attribute it is? It is the attribute of that particular person called Socrates. Okay. Now, how we symbolize predicate logic? In order to symbolize a singular proposition, we need two symbols, one of the individual and other of the attribute. Then we write the predicate symbol before the individual constant. For example, Socrates is wise can be symbolized WS. Okay. The predicate part we write it first, and the subject part we write after the predicate part, and predicate part is symbolized with the capital letter. Now, what is propositional function? A propositional function is an expression which contains individual variables such that when the individual variable is replaced by individual constant, the expression becomes a proposition. For example, the expression X is human. Okay, X, H capital and X small. X is human. Here, human is the predicate of this particular statement. So H is written in the capital letter, and X is the name of a particular representation of a name of a particular individual. So it is written in a small letters. In the individual variable, X is replaced by the individual constant as Socrates. Then the expression becomes singular proposition. Socrates is human. H X. Thus, a singular proposition is a substitution instance or a proposition function. Propositional function is neither true nor false, but a proposition is either true or false. A propositional function that contains only one variable is known as monadic or one-place propositional function, but which contains more than one name is known as polyadic or many-place function. There are two ways of obtaining propositions from propositional function. One is called instantiation or substitution, another is the quantification or generalization. Instantiation is the process of obtaining a singular proposition from a propositional function by replacing the individual variable by any individual constant. For example, singular proposition Socrates is human can be represented by capital H and small s. Okay. Now, what is quantification? Quantification is a process of obtaining a general proposition form from a propositional function by prefixing the quantifier to the propositional function. In other words, asserting or denying a propositional function for all or some of the values of the individual variable is called quantification. That is, quantification is the process of adding appropriate quantifier to propositional function to bring out the formal structure of general proposition. Here we'll discuss about quantifier. We'll see that quantifiers are expression that states how many of the individual or objects have properly in question. Thus, the term signifying quantity such as all, some, every, none are known as quantifier. In predicate logic, only two kinds of quantifier symbols are used to signify quantity: universal quantifier and existential quantifier. Okay, the expression given any x or for all x or for any x or for every x is known as universal quantifier and is symbolized as x. It is used to assert that entities have a certain property or properties. Thus, it is that universal propositions when prefixed to a propositional function stands to symbolize the statements obtaining the words all, every, each, any, their equivalent expressions. Universal quantifier is to be used. For example, the general proposition everything is movable can be symbolized by using universal quantifier within bracket x, after bracket capital M and small x. If we see symbolization of A, E, I and O proposition, we will find that A proposition, all S is P, it can be symbolized as within bracket x and again bracket close, bracket start, capital S small x equivalent to capital P small x. Now E, no S is P. It can be symbolized within bracket capital X, bracket close, again bracket start, capital S small x implies not capital P and small x. Again we can use I some S is P, I proposition some S is P within bracket. The sign what to say, the E is written in a different way. E is written, it is symbol like that, EX, and I have mentioned in the slide, you can see it, EX and within brackets capital S small x dot capital P small x, and some S not P can be represented in that way. I have the way I have stated in the slide. Now what is rules of inference? In addition to all the rules of inference and replacement adopted in propositional logic, for 4 rules, namely universal instantiation, universal generalization, existential instantiation and existential generalization, are requested to determine the validity of arguments in predicate logic. These 4 rules are for introducing and eliminating quantifiers. The rule of universal instantiation allows us to eliminate the universal quantifier, while universal generalization allows us to introduce universal quantifier. Similarly, the rule of existential instantiation allows us to eliminate the existential quantifier, while existential generalization allows us to introduce existential quantifier. Now, what are the difference between propositional logic and predicate logic? In propositional logic, so far as propositional logic is concerned, we find that it considers simple proposition and its atomic or most basic units. The logic assumes that simple propositions are not further analyzable. On the other hand, so far as predicate logic is concerned, it always deals with the substructure of both simple and compound propositions. That is, in predicate logic, simple propositions are to be further analyzed. Again, while propositional logic deals with simple declarative statements, predicate logic additionally covers predicate and quantifications. To demonstrate the validity of an argument, the proof procedures, namely the method of deduction and all the derivation of rules, are used both in propositional logic and predicate logic, but predicate logic requires additional 4 rules of inference to introduce and eliminate the quantifiers while conducting derivation. These 4 additional inference rules are universal instantiation, universal generalization, existential instantiation and universal existential generalization. The symbols which stand for logical connectives are used both in propositional logic and predicate logic, but predicate logic additionally uses quantifier symbols to signify the quantity of the proposition. So in this way I have discussed about the unit 11, that is propositional logic and predicate logic. Dear learners, I think you have understood what I have said. You please go through the unit which is there in your SLM or self-study material, self-learning material, and I think you will be helpful for that. Thank you.